So I'm going to talk about the future of H5Coro. And yeah, I'll just jump right in. So first, I'm going to talk a little bit about what is H5Coro just quickly before we get into what we're looking for in the future. So H5Coro is a independent, written from scratch implementation of the HDF5 standard, actually a subset of that standard. It's written in C++, and its targeted application is reading static data from the cloud, specifically from S3. That's what it was written for. So it's a just a standalone module to read HDF5 data out of S3. It is currently under active development. The program is headed out of University of Washington in conjunction with NASA Goddard Space Flight Center. And this work is being funded under the ISAT-2 program. The project name is SlideRule. I think if you look on the agenda, the links to the SlideRule website, and you can find more information there about that. This is just a little cartoon to give a sense of where H5Coro fits in. If our initial architecture using the HDF5 library would use the REST file connector talking to HSDS, going to S3 with the metadata there and the H5 files there as well. And H5Coro is just a replacement, a plugin replacement for that. It just plugs right into the application. It's statically linked in, and it doesn't need a metadata repository. It just goes straight to the H5 files in S3. Some of the key features of the library. So all the reads are concurrent. If you have a multi-threaded application that's reading H5 data from different threads, they're all going to execute in parallel. There's some locking, but the locking is minimized within the library. So you really do see the reads go out concurrently. It has something called intelligent range gets. So when you read data from S3, you don't have to read all of it. Every object, you can read a subset of that object. And so actually, as brought up, there's a lot of discussion about which chunk sizes you should use, like, should you have a big or small. H5Coro actually tries to predict where in the file the start chunk is and the end chunk is of the data that you want to read, and it tries to read it in as few reads as possible. So that's what I mean by intelligent range gets. The system is serverless, so it's just linked into your application. And as I mentioned, there's no metadata repository needed. Why did we do all this? We did it because it's faster. So we really saw when we moved away from the HDF5 library, and I've given other talks about why this is, but by just targeting high latency, high throughput environments like S3, just having that be the only driver and not having to worry about anything else, we were really able to do some optimizations. And so it's a couple, at least an order of magnitude. We took reads that were taking 2 hours to perform, and we're getting them in now in around 2 minutes. So it was a huge performance improvement. It was actually a big game changer for us on the ISAT-2 project. The current status. So we are actively using this library in ISAT-2 SlideRule system. We just recently added a non-blocking API. So for applications that are not threaded by default, there is now an option to use within the H5Coro module. It can create its own thread pool, and when you do a read, it'll return a future to you, and you can at some later time block on that future to get the results. And then there's a great group out at University of Washington that's doing some seismic research, and they've been interested in the Python bindings for H5Coro, and they've been a huge help there. So we're starting to make some improvements to the Python bindings as a part of the work with that group. In the future, the immediate future, we're looking to add APIs to read metadata associated with data sets. We're looking to add APIs to return like a directory listing of a file's groups and data sets, and also support for the attribute message. So those are just some immediate things. So that's kind of the quick introduction on H5Coro. Now I want to talk about the meat of this presentation and what I see as the future. So what should the future hold for H5Coro? Our goal is for H5Coro to become a niche implementation optimized for reading static data out of S3. That's my selfish immediate goal, is for it to be a niche implementation, not general purpose, a niche implementation, and that it's optimized for one thing, and that's reading static, non-changing data out of S3. Our more altruistic goal, though, and why I'm giving this talk, is that I think that there's a pattern that H5Coro, what we've done with H5Coro, demonstrates maybe a path forward for the community as a whole. And so let me change my goal here and say our goal really should be that for H5Coro to become one of many niche implementations optimized for reading not just static data, but optimized for reading and writing application-specific data. And that's really what I'd like to argue, throw out there, join with other people that may be arguing the same thing as far as a future for HDF5. So how do you handle different applications, right? And so I just made, I took 2 seconds and I just drew a bunch of bubbles on my computer of just different types of applications. These are not meant to be exhaustive. I just, at the top of my head, right? You've got web viewers, you've got real-time, systems that are dynamically updating data sets. You got time series data, sparse arrays, images. You have environments where you're going to big RAID arrays. You have environments where you're doing object stores like S3. Right? You've got all these different things, very different, right? So the environment where you're reading images off of a disk is a very different problem than doing time series out of object store. Like the computer sciencey problem of that is huge. It's very different, right? Now, how do you handle those problems? So our current approach right now is we have a consolidated library. We have the HDF5 library, and for the most part, there's some great work that others are doing, so this is not 100%, but for the most part, it seems to me that all the energy is being put into the HDF5 library, and then tools are built on top of it. And so you have you have your spec at the core, and then there's this consolidated library that one way or the other has to support all these different applications. A different way to look at it would be you keep the spec, right? But you build small libraries now that target different applications. So you say, well, we're running on a network, NFS, and we've got time series data. Like, what are the characteristics here? We want to be in Python, right? So could we build a Python library to read our data over a network that goes straight to the HDF5 file format? That's what I'm proposing. And so now the question becomes, well, what's better? What's the better view, right? I did not put, I was thinking I may do like a advantages, disadvantages. And I was like, if I put anything in writing, it's just going to be an argument, right? Because we can argue one way or the other, like, is this really better? Or that really better? I think just verbally, I'll say, I think the consolidated library supports better code reuse. It's easier to maintain. The improvements that you make in it benefit a larger community right away. I think these are just some quick things that this consolidated library approach has going for it. The special purpose libraries, I think if you can constrain your problem, you can always get a better solution, right? So if you're trying to solve a simpler problem, you're going to get a better performance. That trade just comes with it. So what I'd like to argue, though, is that we don't need to choose. Like, we can do both. And we can do both if we have a tight, simple, stable spec. That's the key. Do we have a tight, simple, stable specification that we're working towards? And so in this world, in this view, if we can center around the HDF5 spec, I would argue right now our community is not centered around the HDF5 spec, it's centered around the HDF5 library. Even though HDF5 is a data format, you know, right, but it's really the library that we're centered around. But if we kind of reorganize our community so it's centered around the spec, well, then the HDF5 library, right away, it becomes a reference implementation. Right? I mean, so you have there, now you have it where it supports everything, right? It becomes the de facto reference for other implementations. And then it allows you to have these other optimized implementations, which can test against the HDF5 library and say, yeah, we're compatible because we can read and write the same files that the HDF5 library does. And it doesn't preclude there being great investment in the HDF5 library for certain applications. I just think though that the switch is though, where are we focused? And I think we need to be focused on the spec. So then the question becomes, what steps can we take to promote the development of these special purpose implementations of the spec in different programming languages and for different applications? Like, what can we do then? I'm just going to throw this out. I'm going to, you know, this doesn't have to be what we're doing. I'm just trying to start the discussion here. I think that there'd be value in identifying a small set of important data models and applications that cover a lot of the use cases. Science data for NASA, static image data stored in H5, right? And now with the Cumulus project, we could say accessed out of the cloud. That statement right there is like 80% of NASA's science data. And so we could say, well, that's one model that we're going to go after. That's one slice that we're going to prioritize. So you come up with this set, then you define a subset of the HDF5 specification that's specifically suited for that. You don't, for instance, if it's read-only, you don't need any of the write parts of the spec. You can remove all of that. You can simplify it. You can standardize it and make it stable, so you're not adding versions to it. That requires money and resources for people to maintain. And then lastly, you build options into the HDF5 library to write and read these files. So you say, okay, if the science subset, you know, or the image subset, we'll call it that, right? So you then, when you write the HDF5 file using the HDF5 library, you just set the image flag, the science image flag, and it automatically knows to constrain the constructs underneath to subset the spec when it writes it out. So I think H5Coro is an example of this, right? So it took about 6 weeks from start to getting a working system. Certainly there's a lot of flaws, but you know, 6 weeks to see first light. A lot of the spec was not implemented. The majority of the spec was not implemented, and yet it works for a lot of the files, not just the files that in ISAT2. The other projects have come to me and it reads those files out of the box. And it says to me that there's a lot of the spec that is not used by most applications. That being said, though, there was a lot that I needed to implement just to get basic functionality. And so I think that there could be work to simplify things. So I know I've only got a minute and a half left. I want to go into a little bit more detail in the last couple minutes I have. So for H5Coro, this is all that I didn't do. All the write operations were removed. All of the free space management was removed. No file driver support and no virtual data sets. Just right off the bat, didn't support any of those. We don't need them. The things like, for us, we were time series, so I was able to flatten any dimensions greater than 2. That's not going to work for other things, but that worked for us, and that simplified our API. We don't support hyperslabs, right? Maybe a certain data model that's super important, but that simplified things for us. And only certain conversions were supported. But let me so these next 3 things, this is just a chart I put together of the spec. And so just to be able to read 1 byte out of a data set, if you want to be fully compatible, you've got to be able to read all these different file structure types and all the different versions for it. Right? And so you have to be able to support fractal heaps and global heaps and local heaps and group symbol table, as well as the header messages. And in some sense, they all, for our purpose, they were all doing the same thing. But I needed to implement a good number of these. These are all the different messages that need to be supported. And again, all the different versions for those messages. And then you have the different data types. So this is my last slide, back of the napkin, right? Okay, so if I just had to make it up 2 seconds and say, well, what would be a good H5 cloud standard, something that someone could take 3 weeks to implement in Python, right? Make it really easy. Say field sizes are only 8 bytes. You only support Superblock version 1. You only support B-tree version 1. You only support data object headers version 2. You support these message types, half a dozen message types. You guys support all the storage and types and filters, sure, right? But right there, I just throw it out there. Like, this is not a hard thing. I think something like this would pay huge dividends for the community. Okay, and with that, I'm done.
Thank you. Thank you very much. John, would you like to jump with your suggestion that you put in the discussion?
Sure. Yeah, so I'm just wondering kind of the maintainability of, every person, going off, making their own library, given that, it is, first of all, writing it is not significant, and then maintaining it will be an ongoing effort. So I just threw out there, what about just creating one library that's designed especially for read-only applications? And that could be, super optimized, support multi-threading, support S3 access. And I think that might be a solution that benefits a lot of people.
And I would like to add that, first of all, JP, we completely understand frustration and with complexity of file format, believe me. It was evolving during 25 years. And it's really not an easy task even to just process all information there. So there are some ways to escape, and going along the lines what John was saying. We see in the ways, first of all, to make our low-level VFD drivers level, where really I/O is happening, be multi-threaded. It is possible, and I will talk about our plans to kind of implement it. It is also possible to, then we have that VFD layer be multi-threaded, then we can rework S3 read only to read to data. So have this parallelization on the low level. Plus, of course, we need to put multi-threading high into the application, but I will leave it alone. So we already have few optimizations that people can try. For example, my two colleagues, Larry Knox and Alexander Jelinek, they took a pretty big file, they repacked it using page deallocation, and then they used the feature that is available in 110, page buffering to optimize performance. And we saw with the Python scripts, performance was improved by 5 times. So there are already some optimizations that can be used, but of course file has to be created, and not all files are created equal, right? So there will be files that do not have, and this is fine. We also can offer, and it will be, I welcome if you have grad student to work with us or someone, a very easy task that S3 driver can be optimized. Particularly, we can create a blob which contains all HDF5 metadata, and then that metadata is ingested on file open, this will help tremendously, because there will be no small IO requests going to fetch up metadata that of many interests. For example, in the previous talk, it was the same problem. Files had to be processed before, big file was concatenated, spending time on the really discovering metadata in the file. And this is one of the optimizations HDF group should think about. So my personal opinion that TG should do more to go multi-threading to allow parallelization on the low level and pushing multi-threading into applications. And then your approach in really standardizing on the file format that can be used for cloud is a good approach. So both, I believe both are valid, but really, as John said, it's not easy. So you were able to do it, and it's great. But I believe it's like maybe we have less than a dozen attempts to do it for 25 years, and I think it speaks the story. For reading directly from HDF5 file.
I see there's a question, hand up from Mark.
So actually more of a comment if we've got a moment still.
Yes,
So I work in the high energy physics community. So we were working with Sun Wu, and the files he was concatenating, these are files that are read vastly more often than they are written. So the work he was reporting on is critical to us, of course, because we've got to be able to write the file to have something to read. But the idea of having a library that has been optimized just for reading would be an enormous benefit to the vast majority of the sort of workflows that my scientific community uses. We are almost never both writing to and reading from a given file in a program. There are many critical analysis workflows that just want to read data as fast as they can to push them through the processing pipeline. So if somebody is working on these kind of things, we'd be happy to talk with them to find out what of what they have done might we be able to make use of. And I think we have a lot of interesting use cases that people could give a try at.
Any other comments?
I have a quick question. How does the vol layer feed into what Joe's suggesting? Once the vol becomes released and supported, can you strip off lots of non-vol stuff and put that in a separate library such that you've got a library that all it supports is going down to the vol layer and the supporting stuff needed for that, and then he could put his Coro under that as a vol and not have to pull along all this other stuff in the library?
So first of all, it can be done right now with the vol connector, but unfortunately right now APIs are not separated. HD5 APIs, they're not come as a separate library or separate module. They're tied into the whole library. And vols, they use, and HDF folks will speak more intelligently to it, they use some parts of HDF5 library like IDs, error checking, data type conversion facilities to be used. So we need to do a little bit more work in separating different layers of HDF5 files. So vol can be created, take just only APIs and deliver HDF5 APIs and real vol connector that does specifically what is done, right, for very limited amount of functionality or specific files. And that vol can be multi-threaded. So if vol layer and vol itself become multi-threaded.
Right, but I know there's been some talks and some work on making the APIs concurrent, not just thread safe. And
right.
So we want to be able to read 200 data sets out of a single file all at the same time. So we want to be able to issue 200 API calls at the application layer, not at the vol layer, but at the application layer for independent data sets from a single file. And we need them all to run all exactly at the same time. So, I think there's still a good bit of work to, even once you make the vol multi-threaded, it's not you're not going to see the performance improvements until you do the work to make the APIs at the higher level concurrent.
Correct. Yes, correct.
But just a quick point to John's comment about maintainability. I think if you can simplify the spec, you're no longer worried about maintainability. So I hope that I'm not maintaining H5Coro 5 years from now, right? Like if you have a simple spec, then 5 years from now, if I'm writing an application in Rust and I'm not going to S3, but I'm going to some, database or whatever, like, new thing, I'm not going to try to backfit H5Coro. If I have a simple spec, I'm going to say, well, in 3 weeks, I can get a solid application up and running, that reads the H5 cloud optimized version of the subset of the spec. And then when that project's over, well, I spent 3 weeks on it, and I'm not going to maintain it. It changes the way we're thinking. We're not investing in the libraries as these permanent things, but we're investing in the spec and meeting around that. So that's just something to think about.
Right. I mean, it seems to me that for a lot of standard file formats, say JPEG, there are many different implementations that can read that file format, and they're written for different reasons. And like you said, the HF5, somehow we think more about the library than about the file format. So I think that's a very interesting take. It might be interesting to see if there's some way to provide more reuse for some of the common, functionality you need to pull data out of the library without going full in with the whole, library framework. But probably other people can comment more intelligently about that.